Hello students, in this chapter on polynomials, we will be taking a look at the definition of polynomials, the degree and terms of polynomials, values and zeros of a polynomial. We will be understanding the factor theorem and the remainder theorem, and then we will be taking a look at some of the algebraic identities. All this would be done with reference to the CBSE prescribed CBSE syllabus for class 9th, and the base for this particular lecture is going to be Advisor's Mathematics for class 9th, written by Professor K.C. Sinha. Today we are going to take a look at the chapter Polynomials for class 9th. We'll start from the basic definition of what a polynomial is. A polynomial in X, as you can see on the board, a polynomial in X is an algebraic expression in X in which the powers of X are only whole numbers. I have underlined a few terms over here and we'll be critically examining each of these underlined terms. What do they mean? A polynomial, which is what we are studying in X. Here, this X is called the variable. X is called a variable. Variable is an alphabet that we use to signify something that is going to change its value. It's not going to remain a constant, and hence it's called a variable. For example, the number 3 is a constant. The value of 3 is not going to change. Whereas in some equations or some expressions, you would be observing that there will be some variables which will keep on changing their values. So X is essentially a variable that changes its value. So a polynomial in X, there could be many variables, right? For any expression, you could write an expression with many variables. For example, sum of 3 things is 10. So those 3 things could be A, B and C. So A plus B plus C is equal to 10 would be a governing equation. Now here A, B, C can take any value if it is not given, if there is no restriction on them. So A, B and C can take any value, hence all of A, B and C are variables. But what we are going to study is a polynomial in X, that is in a single variable. What we are going to confine ourselves to would be studying about polynomials in a single variable. There will be just one variable in the given expression that we will be studying. What kind of expressions are we going to study? We are going to study only algebraic expression. What is an algebraic expression? An algebraic expression is an expression that involves simple operations, mathematical operations like addition, subtraction, multiplication and division, and it should involve variables and constants. That is called an algebraic expression. We will be seeing the general form of an algebraic expression as well, but let's first get the whole definition right, then we will be getting into what a general form of an algebraic expression is and how would you identify whether a given expression is algebraic or not. So a polynomial in X is an algebraic expression in X in which powers of X are whole numbers. When there is an expression, for example, all these are expressions. In these expressions, there is X. There is just a single variable. There is only one variable in each of these given expressions which changes its value. So a given expression will have various powers of X. X, X cube, X square, X to the power 5 root X. So that is what the powers of X is, and for any expression to be classified as a polynomial, the powers of X have to be only whole numbers. It cannot be a fraction, it cannot be a negative number. It has to be only whole numbers. So if a given algebraic expression satisfies all these underlying conditions, then you can say that it is a polynomial in X. Now let's look at this using 5 examples here. The first example says we have to identify whether each of these is a polynomial or not. So you have x square plus root x. Here it is an algebraic expression because it involves only addition, subtraction, multiplication and division. It does not involve any other operation, any other expression, trigonometry or any other expression. Hence it's an algebraic expression. So that condition is satisfied. It just has one variable x, that is satisfied. When I say x, we can also write y. X is just symbolic of the fact that there is just one variable. So x squared plus root x is an expression, is an algebraic expression in X. Now the powers of X here is 2. So it is a whole number, but here the power of X is 1 by 2 half. Root x is equal to x to the power 1 by 2. Hence, the third and the last condition, that the powers of x, all the powers of x have to be only whole numbers, is not satisfied. Although here it is satisfied, the second term does not satisfy it. Hence, this is not a polynomial. Coming to the second term, it again has just one variable x, and it is an algebraic expression. So the first two conditions are satisfied. The powers of x, here the power of x is 1. Is there any other x in the given expression? No. So we will have to consider only this. Even though there is a square root over here, square root of 5, but it does not involve any power of x. Hence, we can safely say that all the powers of x given in the given expression are whole numbers, and hence it satisfies all the conditions to be a polynomial, and hence this is a polynomial in x. Now the third one, it says x cube plus 1 by x cube. The power of x is a whole number, the power of x is a whole number. It is an algebraic expression, and it just involves one variable. So can we say that it is a polynomial in x? No, we still can't say this. When we are looking at the powers of x, we have to take all the powers of x in the numerator. So here it will become x cube will remain x cube. When x to the power 3 goes up, the power turns into negative. So here we see that the power of x is a negative integer, and hence it is not a whole number. Hence this condition is not satisfied. Thus this expression is not a polynomial in x. The fourth one, it says x square plus tan x. Does this involve just one variable? Yes, it just involves one variable x. But is it an algebraic expression? No. This is an algebraic expression, but this, when you have a tan, once you start studying about trigonometry in class 10, tan theta or tan of any angle is a trigonometric expression. So it is a trigonometric function that we have involved here. It does not involve only addition, subtraction, multiplication and division. Hence this is not a completely algebraic expression. So that condition is violated. Hence it cannot be a polynomial in x. What about the number 3? 3 does not involve any power of x. Does it have any x? So you might be tempted to say that this is not an algebraic expression in x because there is no x here. But what if I say that 3 can be written as 3 into x to the power 0? You must have learnt it in the last chapter that a to the power 0 would always be 1. Any number to the raised to the power 0 would be 1. So 3 that was given earlier could be written as 3 into 1, and 1 could be written as x to the power 0. Now we have involved an x here, and is the power of x a whole number? Of course, 0 is a whole number. Hence all the conditions that are given for classifying any expression as a polynomial are satisfied here. Hence this number 3 would qualify as a polynomial in x. This particular type of polynomial, which does not involve any power of x or which involves only the powers of x equal to 0, is called a constant polynomial. We will have a look at it in the next segment. Now let's get to the algebraic expression that we had started with. What is the general form of an algebraic expression? Any polynomial in x is written as this. Any polynomial in the variable x. Here instead of p you could write q, a, c, d, any alphabet that you want to. It's just used to symbolize it. It's not as if since it's a polynomial, so you have to write p. It could be any letter, but just for the general sake we write p here, and in the bracket you write the variable. Here I have written x, it could be y if the variable is y, a if the variable is a, or anything here. It should just have the variable. So polynomial in x, and this is read as polynomial in x, is the general form is this is the general form of an algebraic expression or a polynomial in x, where a0, a1, a2 and all these are coefficients. They are constants, and you have the variable is x. Now there are a few other things to note in this expression. Let's observe it a bit deeply. So what are these a0, a1, a2? This is a general form of an algebraic expression. You could have these or you cannot have these, but this is a general form. It should involve terms like this. a0, a1, a2 are called coefficients. Any term, any constant term that's multiplied to any power of x is called a coefficient of that particular term. This you must have this you must have studied in a previous class. So here a0 would involve a0 into x to the power 0. So a0, a1, a2 are all constant numbers that have been multiplied to various powers of x, and hence they are called coefficients. They are constant numbers, they do not change their values, although I have written alphabets here, but it is clearly stated that these coefficients are constants, they do not vary, they are not variables, they are constants or coefficients of the variable x. Now here we have written a general form where the powers of x are written in increasing order. You may have certain terms, you may not have certain terms. For example, if a1 becomes 0, the x term would not be there. So if you have an expression 3 plus 5x square, if this is a polynomial, it could have been written as 3 plus 0 into x plus 5 into x square, right? So here the a0 would be 3, a1 would be 0 and a2 would be 5. So this particular general form can be used here. So this is the general form that we are using for any kind of polynomial algebraic expression in x. So these are the coefficients. Now these are the powers. What is n? N is called the degree of a polynomial. Once you identify a polynomial, the highest power of x in that given polynomial is called the degree of the polynomial. So here if we see, there are two polynomials here. Once you have identified, for a non-polynomial it will not have a degree. A polynomial's degree would be the highest power of x in that expression. So here the highest power of x in that expression is 1. So the degree of this particular polynomial is going to be 1. Similarly here the highest power of x is 0. Hence the degree of the polynomial is going to be 0. So there are a couple of important terms that we have identified here. One is the coefficient. Coefficients are the constant numbers that are multiplied to different powers of x in a polynomial in x. And degree of a polynomial is the highest power of x in that given expression. It is not the value of coefficient. Please note, it is not the value of the coefficient, but it is the value of the highest power of x. That is the degree of a polynomial. So now let's take a deeper look at what this number 3 is, and what would you classify 0 as? Since 3, as I said, is a constant polynomial, does 0 also qualify as a constant polynomial? Let's have a look.